Uh, some of the introduction has been done about me. This is my second startup, and in 2012, I passed from IIT BHU, same with Pratik. We did our first startup in 2014. It was a consumer tech startup. I worked as a supply head over there. I aggregated hotels, which were sold to the customers. He used to do data science over there. And post that, we started our own AI consulting firm. We used to build machine learning and deep learning models across various verticals like e-commerce, finance, IoT, different kinds of problems. So we did it for 6 to 7 years approx. And in 2022, we came across an image generation problem for a client in Dubai. And in those times, DALI 2 was not launched. It was in very early stage. We used to generate images in almost 24 seconds, one image, and it was kind of very hazy image. And that's why in those days, AI images were getting used in AI art. So one of our friends, he was doing crypto, and he invited us to launch some NFTs, and that's how we came into the world of generative AI. Okay. We have a lot of exposure with videos and commerce earlier on, so we decided to embark on this journey of the video. We had a lot of exposure with the problems that end user, like lower set of users face with the videos. And we understood these problems, we understood AI. That's why we have founded BingeClip AI to solve the problem. The motivation is pretty much simple. I will just zero down on the motivation a little bit because it is a problem statement we are trying to solve. So uh, just like a consumer in the day-to-day space, especially the Gen Z audience, they on an average have a video app in their mobile phone. Usually VN is one of those apps. Remini is also one of those apps. And it's a very simple kind of apps. It aggregates all your photos and videos and makes a sensible, presentable story out of it. Okay. And in India, it's a very big trend. India is surprisingly second largest video creator audience in the world. It should not be like this, but it is there. Okay. We find that these audience are going into the companies and they are working hard in those companies. And everyone knows that in whatever work you do in your company, presentation is one of the biggest skill that has to be there to present that knowledge out there to the teams, to your customers, or to all the stakeholders that you are working with. Okay. That's why we have a PPT industry. Okay. But all of this audience understand the importance of videos. They crave for a tool which can convert all these documents into the videos, all their knowledge work into the videos, so that they can present what they want to present. It should be in terms of story. Everyone wants to listen a story because of the attention span problem, time limit problem, understanding problem, domain expertise problem. There are n number of problems. Okay. Okay. So, but when we started working with this kind of people, we thought that Canva is solving all the problem. Canva is a drag and drop editor. InVideo is a drag and drop editor. We have other kind of drag and drop editors also like copying. Okay. But we realized that there is a lot of gaps which is still not filling the gap for these users. The first gap was very, very important one. They want very much accurate information to be there in the video. It's a knowledge work. The information has to be accurate. Okay. Let's say there is an agri person, there is an insurance person, there is a loan person, okay, there is a health person. एक image, एक video clip, एक fact भी गलत नहीं हो सकता. ठीक है. It's very, very important part for it. So all the information, the first information problem statement was कि all the information must come from a knowledge base. Okay. Second part is the visuals, again, all the information must be very, very accurate. Okay. And most of the text to video editors or even the editors like drag and drop editors, they are not facilitating it. They are making this kind of problem a kind of clumsy editing problem. Okay. You have a timeline based editor, you have your own clips, you can put that on timeline, but then that footage will not be processed, it will not be trimmed, it will not be clipped. Okay. And this everything makes it an editing problem. And this is where the user goes out of the picture. Okay. Then the third part, when you ensure these two things, then comes the design problem. Okay. Okay, we have collated all the facts together. We have put that everything on a timeline. But I don't know how to design color, fonts, typography. Sorry, fonts and typography are same, but colors and typography and also the visual elements that should be there. What should be the flow of the process, animation that we want to do. But most of the users are not acquainted with it. They just consume it, but when it comes to application, they are not able to do it. Okay. This is the third level of problem. that we face. And the last one is the editing flow. Okay. When it comes to edit the video, it's the most clumsy part, just like in the software development. AI can write all the code for you, but the hard part is debugging. Okay. So these problems, for a statement, we decided that this will be the core moat of our product. Okay. And we started working on it. We started working on a video product where you can write a prompt, you can write an idea, you can write a script. Okay. You can ask a question, and a video comes out. Okay. And the idea is that you should edit it bare minimum. Okay. Uh, so we started working on this tool, and what happened is we started getting a lot of use cases, which was not social media centric, but communication centric. Like you want to communicate to your customer, and you want to send personalized message. Like uh, there is a loan customer. He wants to. You have sent a product video. कि ये मेरे loan का video है. This is how health works. This is how loan works. But they have an objection कि I am not comfortable with the interest rate. I am not comfortable with the premium. Not comfortable with the payment tenure. Similarly, in agriculture, people tell about कि this fertilizer will work for your wheat crop, but he told कि I overdosed this wheat crop last year. This fertilizer is not working. What should I do? Take care. So in those scenarios, what happened is asking a knowledge base and generating a video out of it was very, very useful use case that came into the picture. And we started to work on it along with the text to video editor that we have. So right now our product should involve three kinds of things. We generate and edit video. Okay. We store them. Uh, while storing, we generate the tags automatically, the titles automatically, the descriptions automatically. And in the last, when you ask a question, we give a query. We judge the intent, and we give you an accurate video out. And this is done usually on the chat. So I'll just show you one video, how it is working. But today here, we will talk on the core component only, which is video creation and video editing. Okay? So please play the video. So this is just one demo. So you write hi, it asks you to generate a video, you select a language, and it tells you to ask a question. Okay. So the person has asked a question about three diseases of potato, and video generation happens. Now there are two kind of stuff here. First, see the video, and I'll explain about the ETA. Here we need the volume. Sorry about it, but it has a legit volume. So you can see that all the visuals and facts are accurate about these videos. And this is what our customers are seeking. Okay. So this is one of our product offerings, but the main core product is the video. Okay. And I think Prateek will start on how we are solving everything step by step, like the knowledge base part, video search part, and the last part, editing, will be covered by me. So.
Hello. Hello. Yeah, good afternoon, everyone. So I think Abhijit has already covered the introduction part, so I'll straight away move to the components here. So while watching the video, you saw there are two components to video creation process in our stack. One is script to video, and the other one is query to video. So what is query to video? When you have a knowledge base attached to your system, then basically you have a query, you get the context from that knowledge base, and then you generate a script, and then you basically go to the script to video creation part. First, I'll explain the script to video part, and then we'll get to the query to video. So script to
बताना जब भी आए.
हाँ. So script to video, in essence, we assume that whatever demo you saw on the WhatsApp, let's say we assume that the user already has a script in hand, and now once you have the script, the next process is basically doing the script analysis part. So what we do is, based on the language, whichever the language was selected by the user, we convert that script into audio using TTS, and then we have a word level timestamp with us. We put that timestamp data plus the actual script into the script analysis module, which you can see here. What it does is, it is nothing but an LLM, but we have done a lot of prompting there just to make that very, very smart. What it does is, basically it converts that script into scenes. and scenes in such a way that the logical flow should be there in the video synchronization part, and it should be coherent. So the script analysis part is basically converting the script into scenes, and we have a lot of components in that data, where for every particular scene we have start time, end time, uh, tags, context tags, duration, and the most important part here is the search query. So what do we want from that particular scene? So we have like 3 media integrations. For every scene you just saw the video, there can be avatar, there can be image, and there can be videos. So the search query part for every scene is very important. So that is where the entire, you can say, the crux is. If you don't have the right search query, you will not have the right media assets. So that part is done. Once that is done, we basically do this integration. Avatar selection part is basically given to the user. A user can select, we have pre-made avatars with us. User can select the avatar, whichever avatar they like. And these are all, you can say, real avatars. These are not AI avatars. So the realism has to be there. Then the image and video part, I'll explain in the next slide. The search part, like where exactly is the search happening. Post that, what happens is, once you have the scene level information, you have all these, you can say, media integration part done, you basically get to the theme part. So what is the theme which any particular clip is saying? Because that is important. We have basically some templates which we have pre-designed for every particular theme, and some are AI generated. So theme is nothing but design, you can say, for every clip. Once that is done, we basically have the text overlay part. Text overlay, it is actually not written here, but yeah, you just saw the video where whatever you are trying to speak, if that text is not in sync with whatever you are saying, then it's not relevant. And again, the most important part here is it has to be in sync with the avatar also. It cannot be like, and same is true with images and visuals. If you're saying something about a potato disease, and if you don't have that disease in front of you, it's a problem. And same is true with text. You cannot just say anything and the text synchronization is not there. So that this is where the timestamp data comes into picture. And yeah, once that is done, what we do is we basically render all the clips individually. And the most important part here is, if let's say we have a scene and we convert that scene into, let's say, 7 clips. So the 7 clips have to be processed in a parallel manner. That is very important. It cannot be sequential. So the crux here is the scene segmentation part. If the scene segmentation part is not done in such a way where the dependency is not, you can say, uh, not attacked, then there is a problem around what you do in terms of doing the parallelization part. So the moment we have clips, like the video which you saw, for a 1 minute video, we take 2.5 minutes just to render that video. And we are constantly basically reducing that time, but that is the core purpose, that you have to parallelize everything. You cannot do sequential computation. And some of the computations are really, really, you can say, heavy. So they take a lot of time, GPUs also. Once that is done, final rendering is done, and then you get a final video. We attach music on the background, and you get the video accordingly. So this is the script to video part. Yeah, I think I already covered this, but yeah, like I said, avatars, you can have personalized avatars also, which you have. Like we are dealing with agriculture-based companies who want agriculture-based avatars. We are dealing with insurance-based companies, healthcare companies. So they want avatars who can basically have a, who can relate to, like users can relate to those avatars. They cannot be like just AI avatars. And images and so coming to the images part, we have 3 you can say options here. One is integrate your custom images also. Like for example, if we are working with any particular company, they have their custom image dataset also with them. So do we have a process where we can integrate those custom images into our pipeline? Yes. If the custom image is there, let's say if the custom images are not there, then we basically search those images in the stock library. So there are a lot of stock libraries which are open source. They basically provide you open source, as in they provide you the asset according to your search query. If even if like we don't get custom images or the you can say stock images, we basically generate those images on the fly. So that is again one option. Similarly for videos, we are right now only dealing with custom videos and stock videos. We don't generate clips because that is the essence. If if we are able to generate clips, then we are able to generate the entire video also. So that is not what we are doing right now. And then there is a sync text part, which I already told you. So yeah, this I have already covered, I think. Yeah. So from our understanding, what and the business context also is important here. The most important understanding here is the script has to be accurate, which is very very important, and the visual part according to that script is has to be very accurate. If you are working in the text to video space, and if we are integrating any third party images or videos or custom images, if the search is not working properly, then the relevancy is going for a toss and the engagement is dropping. That's what. And एक नॉर्मल वीडियो बनाने में इतना वक्त नहीं लगता है, बट एक अच्छा वीडियो बनाने में काफ़ी टाइम लग जाता है. दैट्स व्हाट द learning is. So we focused our you can say the core of our entire stack is how do you basically do proper searching and how do you do proper scripting. These two parts are very very important, and then we'll come to the video operations part. So scripting में sorry search में the important part is you have to be context aware in terms of visual search, because here what is happening is for every scene you are having a text query and you want a visual asset for that text query. So that is kind of a multi-model embedding which we are talking about, because what happens is if you are having a text embedding model and you are having a visual embedding model, they need to be present in the same latent space. Otherwise the similarity won't come what you're looking for. So inherently text is kind of sequential, and it is you can say symbolic, but when it comes to video or images, there are a lot of spatial features, and it is temporal dependency which you call. So creating embeddings only for text-based models and creating embeddings only for visual like images models is not going to solve the problem. You have to take a path of multi-model architecture. So after doing a lot of you can say ifs and buts, we did a lot of iterations also. We basically, the core foundation here is how do you bridge the gap between text and visual semantics for similarity, because similarity was not coming. Initially what was happening was we have a text which is basically a search query. We pass that text into an embedding model. You get the embedding. Now you have an image, let's say. For image, you generate metadata. You have the tags. Sometimes the user only gives you the tags in their systems, from their systems. But you have to convert that tags or metadata into embeddings, let's say. Again, this is something which was not working. Why? Because visual features are not coming into picture. You are ultimately what you are doing is you are basically having the metadata, you are converting that metadata into embeddings and just giving the text to text similarity only. So it was not that accurate, and accuracy was very very important for whoever we were working for. After this, we did the most important part is we have to get to the model which is basically having text and visual embeddings trained in a shared latent space. If we don't have that, we cannot do that. Clip is again OpenAI's very very robust model, but again it is you can say it is trained on the web data. So that is the problem. We had to do this on a you can say custom data. So we fine-tuned clip models for our agriculture-based data. Same is true with VideoBERT. VideoBERT is again for image. It is again a core architecture is transformer-based only, but it is for video. Sorry, not image. It is for videos. So how do you basically convert the video into scenes, and for every scene, not scene at actually frames, how do you convert embeddings from those frames and basically do the similarity with the text which we are having. So these two models are the core which we are doing. We do a lot of fine tuning also. Then there is a semantic search approach which is normal, and the database which we use is PG vector. And vertical fine tuning is very very important. Like I said, the video which you saw is of agriculture. So if we don't provide relevant data, we don't get the accuracy which we are seeking from the general models, because these models are definitely good, but these are not good for custom data sets. Same is true with healthcare data, and same is true with insurance data. So this was around script to video part. The video operations I've already covered. Again, the second important part is query to video, and this is where our, you can say, the focus was, because a lot of people are asking that we have a knowledge base, we have answers to all the queries, but we cannot have a video on the fly, which you just saw. So query to video is something which is again very important. And knowledge base, when it comes to knowledge base, you can see user is basically giving you the query, you do the query analysis, you do the script generation part, which I just explained, the same thing, and the completed video part. But here is the most important part: how do you retrieve that information in a very, very, you can say, concise manner? Because if you don't have that information with you, again you will lose the context, again it will have a ripple effect on script generation, and it will have a ripple effect on video generation. So again, if you are asking for, let's say, the video in which we saw, give me 3 diseases of potato, and in the knowledge base, if you don't have potato ka koi bhi disease ka data, then again it will go to the LLM and basically get the data. But what if instead of 3, you only get 2? What if instead of potato, it was not able to understand that context really well? Potato ke jagah kuch aur ho gaya, wheat aa sakta hai, because there are a lot of crops which we have in our database. So the information retrieval is very, very important here. And that is where the next part, the RAG part, which comes into picture. Next. Yeah, this is the accurate scripting part for, you can say, vision enhancement. So you have the document processing workflow with us. We have the document processing workflow with us. What it does is basically whatever is your knowledge base, whatever kind of modality you are having in documents, we just put it, and unstructured.io, we use unstructured.io for basically getting the right elements from every document. But the most important part with us was there were a lot of documents which were having text data, image data, documents, PDFs, Excel, CSV, HTML, everything, on top of it multilingual, because we are catering to vernacular audience in India. So if you don't have the retrieval at place, then that becomes really difficult. So unstructured.io really provides a good, you can say, element-wise contextualization of whatever context you are needing. That is one. But the most important part here is you cannot use that context directly. So what we do is we convert that context into the, map that context into the page, whatever page they are talking about, and ultimately to get the context for that query, we pass on the entire image. We don't, again here we are relying on multi vision language model, where along with the question, we pass on the image of the context to get a better understanding. Because what happens is if you only give text, then there is a problem. Then there is a search, then there is an accuracy problem which we have faced. So we generate embeddings accordingly, and we basically, you can see the visual retrieval part, we retrieve the entire page image associated with the relevant part, and basically get to the search part. Once that is done, contextual reasoning is there, and we get a better output. Still, this is work in progress, but yeah, that's something which is done. Once we have the accurate extraction of, you can say, script, we do the script to video module, which I already explained. So this is, you can say, accurate scripting.
So yeah, I'll cover the editing part, and this is one of the most crucial part which differentiates the product from all of the products. What happens is generation will happen, and there will always be some inaccuracies in generation, and user will like to edit that video. And with AI video editors, there is a lot of scope which is increasing in terms of what kind of edits you can do. So I will categorize the edits into two parts. One edit is you want to make an edit to overall video, like you want to change the language of the video, you want to change the length of the video, you don't like the tone of the video, you want to adjust it to the audience. Let's say your audience is, like, you say, someone from 18 to 25, you want to change the color, tone, templates according to that. What is happening currently in tools like Canva, you'll have to switch the template altogether, and which is a very costly task. Sara content, everything that the text, images has to be transferred from one template to the another template. So it's a very, very costly edit that has to be done. There are second kinds of edits which are very, very simple stuff where user wants all of the control. They want to change the asset. Let's say we saw the video where there were some disease images over there. he doesn't like the disease images, she doesn't like the disease images. That images, the exact images has to be changed. They tell we have better images, we can upload it and we can put it over there. So these kind of edits are very, very accurate one where a user wants control. So we have divided the UX into two parts, and what has happened is one is text-based editing and another is drag and drop editing. Okay. And for that, what we have done is in backend, we have created a DAG architecture. We have divided the video into layers. We start from the background, we go to the template, we go to the components of the template, which are avatar, video, and images that Pratik told us. And then to each of the components, there are effects and animation attached to the component. And then in the last layer, we have text and we have effects of the text. This is how our DAG architecture is arranged. Okay. We have created a UX where we have given a simple drag and drop interface, which adjusts these elements of the DAG. You want to change the text on the screen? Okay, no problem. Okay, you go and edit the text of the screen. It will directly update it into the DAG. But what happens if you want to change the theme of the video altogether? Okay, so that's where the agentic flow works for us. This is the where we found a real use case of agent in our editing process. So we put an agent, we put an editing agent on the top of the DAG, okay, and it takes a text query. Let's say text query is adjust my video to the audience between 18 to 25. They like the video more colorful. Okay. So the first part is understanding that query, breaking it into the actions. Okay. And then the DAG agent decides which of the subgraph which will be executed for making this change. So in this kind of scenario, the subgraph which will be getting executed will be the template part. And since it's a hierarchical structure, so first, the moment you select the template, the DAG ensure that the rest of the elements will get automatically updated. Okay. And this is how we are creating an intelligent agent which is kind of there besides you. It takes instructions from you and adjusts the video accordingly based on their own intelligence. This is where we are moving from a simple drag and drop editors towards the Premiere Pro features, towards the features which are inside the DaVinci Resolve. It's not the frame by frame features, but the advanced features one. Okay. Let's say, for example, you want to change the length of the video. Okay. So in that case, what will happen? It will skip the background, it will skip the template layer, and it will come to the scene layer, which is the component part. Okay. It will rewrite the script altogether. It will split it all together, and then whole of the DAG will get executed again. Okay. So this is the first part. This is how the function is getting allocated by the agent. The second part is the compute. Okay. So we have several components, like there is a lot of components which is running in a video tool. Okay. And right from the search to avatar lip sync, a lot of things are happening over there. And some of the components are really compute heavy. And we need to know in real time that how much compute is getting allocated in which of the component while video is getting created on scale. Okay. So these agents give us an overview of if, let's say, at one point in time, let's say 1,000 videos are getting created from our APIs. So from which parts the compute is getting allocated. This has really helped us in saving the compute cost. Okay. It's exactly the A100s. So yeah, this is our editing flow altogether, and this ends our presentation. Okay. And we are inviting questions. If you have any questions, please ask us. Yeah, please.
So you have image retrieval or image generation, right? For the prompt to video. So in that, are you like using generative AI or you are trying to like grab some images from the web?
Right. So, bro, my cousin.
Yeah. So text to image you are saying, right? For image retrieval you are saying.
Yeah. So you are also grabbing some visuals to like paste it beside the avatar,
Yes.
right? While the video is
Yes.
getting created. So is it Gen AI images or you are like
Yeah.
getting it from the
So yeah, so there are three categories to it. One is, let's say you are a company and you already have image database with you. So the first part is the search part. Like if you already have the image, we don't generate it. Uh, Second is, let's say you don't have the company dataset with you, but still there are a lot of good images which are already there on the internet. So stock images. So according to the search, we basically get to the step 2 part, which is the stock image part. Still, if we don't get any relevant search, then basically we generate it. So once you like, get to the generation part, it's like normal text to image algorithms which we use.
And the second part, so you have two GPU intensive tasks, right? One is script generation, image retrieval, and another GPU intensive task of like rendering. So what is the typical like split of like GPU compute? How many hours or like compute time you are like spending for rendering and for script generation?
Yeah, so effectively script generation, you can say, is not GPU intensive. Okay, the major GPU intensive part in our entire workflow is, you can say, the avatar syncing part, the avatar lip syncing part, which takes a lot of GPU, and the video operations part. Because video operations, like I said, there are like let's say 7 to 8 clips for every particular video. If they are happening in parallel, you need to have robust GPUs. So right now what happens is, like I said, the compute time for us is, if you have a 1 minute render video, if the render time of the length of the video is 1 minute, the render time for us is 2.5 minutes. So that is coming with, you can say, right now, if I tell you the number of GPUs which run in parallel for that is basically, you can say, a heavy container, a heavy machine with 8 containers is fine. Okay, but this we can easily create 2,000 to 4,000 videos with this. Let's say you want 10,000 videos, you want 50,000 videos, you want 1 lakh videos, because the personalization part is also there. Then on the fly, what we do is we multiply those servers with GPUs. Yeah.
Split.
Acha, you're talking about the split part. Avatar generally takes 30 seconds. You can say avatar is the most crucial part. You can say 30 seconds for you can say 20 to 25 seconds of video. So for 1 minute, it takes around 1 minute. So that is the split.
Yeah.
Okay, one last question we can take.
So you spoke about the importance of different segments being independent of each other, right, during the script segmentation phase. So considering the limited time of the video, let's say 1 minute or 2.5 minutes, so how do you ensure the important information of the script is retained in the video, and also ensuring that too much text is not getting overlaid on the video, like so that the user doesn't have to re-edit it during the editing phase multiple times? Like,
Yeah.
how do you balance it out so that you can still run the pipeline, like you said, in parallel fashion to save time?
Yes, yes. Actually, that is the most crucial part, and we are still, like I said, work in progress. Because what happens is, if you have a script, and if those scenes are not, generally scenes are dependent on each other,
Right.
right? But the problem is not dependency of scenes. The problem is, which we are trying to solve, is the components which you generate for that particular scene, they have to be uh, orthogonal to each other. You can say as orthogonal as possible in terms of information.
Got
We are
it.
not saying that visually एक चीज दूसरे से dependent नहीं है. That can happen. But the components which are important for any clip generation, if those components are dependent on your the next and the previous clip, then it becomes a challenge to run everything in parallel. And frankly, there is a challenge. So that's why we don't get accurate videos also sometimes. So that is still like a lot of work is going on in the script analysis part. How do you write the prompt? How do you write the prompt in such a way that, okay, you have the script, you convert that script into scenes with n number of components which you want. At the same time, they have to be interdependent. If you want any context, you can pass a context tag. एक पोटैटो एग्रीकल्चर की बात हो रही है, तो एक कॉन्टेक्स्ट है एग्रीकल्चर का, तो यू कैन पास दैट एग्रीकल्चर का इन डिफरेंट सीम्स, डिफरेंट क्लिप्स आल्सो. That is what.
Got it. So based on your experience, right, in the entire pipeline, you answered a bit in the previous question as well. If you are generating 1,000 videos and you are doing compute optimization, right, where have you seen the most amount of compute being taken while running it? Which phase it is?
Lip sync.
Lip sync.
Lip sync takes a lot of time.
Lip sync and vision search, these two components. Like when vision search gets really intensive, it takes a lot of compute. Like it involves looking inside the videos and the image itself, because हमारी use case is वैसे ही.
Thanks a lot.
All right, so that was the session from Abhijit Singh and Pratik Khandelwal. Guys, please clap for them. Give them your
Thank you.
encouragement for that knowledge sharing. Thank you, Pratik and Abhijit.
Thank you. Thank you, everyone.
Thank you.